Exercise 2, which is about the work, energy, and power. As we did the first 17 questions, I have already recorded. So we discuss with question 17 and onwards. The whole exercises are having questions related to work, energy, and power. So first 17 are already recorded. So we'll start with question 18. So question 18, on a day with no wind, a fountain in Switzerland propel 30,000 kilogram of water per minute. Like every minute, 30,000 kilogram of water is being propelled, means pushed up. Calculate the power used in raising the water. So first thing, whenever you're solving a question, you should always write a formula. Okay. So what is the formula we use for the power? So the formula which we use for power, you can write a symbolic, like you can say power is work divided by W over T, which is a symbolic, or you can also write in words that power equals work divided by time. Then what about the work? Work is force into distance. So we can also say the power is equals to force into distance divided by time. How much force is applied? What force is applied? Whenever you're lifting an object, what is the minimum force we apply? The force which we apply is always equals to weight of an object, like mass time gravity. Whenever you're lifting an object, the minimum force which we apply should be equals to weight of an object. And weight is mass into gravity. So mass is 30,000 and the gravity is 9.81 or 9.8. So the force will be equals to 30,000 times 9.8. Multiplied by distance, how much distance we move. When we propel, we move to a height of 140 meters. So distance will be 140 and divided by time. How much time it took to propel this? It's minute, but time should always be in seconds. So 1 minute equals to 60 seconds. So when we substitute this all, we will get the power. So 30,000 times 9.8 times 140 divided by 60, which is approximately equals to 7 into 10 to the power 5. And the unit of the power is what? This is rounded of answers, 7 exponent 5 watts or 700,000 watt or 700 kilowatt, you can also say. The next is efficiency of the pump which operates the fountain is 70%. Calculate the power supplied to the pump. So there is a pump and it is the power which is used to lift, that is 7 into 10 to the power 5. We have to calculate how much power it intake, like power input. And it is only 70% efficient, like 30% of the energy is wasted. So how to work out this? So the formula for efficiency, as I mentioned, whenever you're solving a question in physics, always write the formula. So don't write in, so like don't just directly solve, always write the formula. So efficiency, you can write the formula in symbols, you can write formula in word. Efficiency is equals to the useful power multiplied by 100 divided by input power. So efficiency, it is 70% efficient, so 70. What is the useful power? How much power is useful? Because that is the power which it used to lift the water, which is 700,000. So the useful power is 7 exponent 5 multiplied by 100 and the input power is unknown, that is x. So if you need input power, x will be multiplied, this will go there in division. So what is x here? So it will be 7 exponent 5 times 100 divided by 70. So this will give us how much power is being used like input, when we simplify this, it will be 1 exponent 6. The value of x is equals to 1 into 10 to the power 6. And the unit of a power is what? 1 exponent 6 is called mega. So you can also say 1 megawatts. Or you can also write 1 exponent 6 watt. On another day, a horizontal wind is blowing. Like the pump is propelling the water and there is a horizontal wind below. The water does not rise vertically. The water, like because of the wind, the water does not rise vertically, but it rises to a same height of 140 meters. This was 140, this is also 140. So even though the wind is blowing, the water rises to the same height, even though it changes a different trajectory, the path. So why it rises to the same height? Because when the wind is blowing, wind is not affecting the vertical motion. Wind only affects the, because like wind is not moving up top to bottom or bottom to up. It's moving right to left or left to right. So as a result, what will happen? Because the wind has no effect on the vertical motion of the water. That's why it rises to a same height. The force of the wind is horizontal only. It's not vertical. If the force of the wind was vertical, for example, if the pump was pushing the water horizontally and the wind was blowing, now this will have effect, like it will change the trajectory and the range at which the water will move. This will affect, like without air, if there was no air, it will move to a longer, like have a longer range as compared to when there is air present. But in the question, the water is being propelled in the fountain vertically upward and the wind is moving. So it will cause it's not affecting the vertical motion. So the answer here, wind will not affect the vertical motion. It will only affect the horizontal motion. The next question, 3.1, figure shows a water falling over a dam. As you can see, the height is given 7 meters. They calculate the potential energy lost by 1 kilogram of water. So whenever you're solving a question, 1 mark is for writing a formula. To get the potential energy, it is mass, gravity, and height. So what is the mass 1? What is the gravity 9.8? And from what height it falls 7. So you multiply all of them. So 9.8, it's actually 9.8 multiplied by 7, which is 68.6, and the unit will be joules. Assume that all the potential energy loss is changed into kinetic energy. Calculate the speed. So how to work out the speed? Whenever such question is there, we consider the gravitational potential energy is equals to kinetic energy, or the kinetic energy is equals to gravitational, if there is no loss. Kinetic energy is half mv square and gravitational potential energy is mgh. Here m will cancel with m. So whenever there is no loss of energy, you can write this, that half v square is equals to gh. You can use this. So if I need the speed, this 2 is divided, other side it will be multiplied. So v square is equals to 2gh. The speed square is equals to 2gh. And if I need the speed, so I have to take a root, square root. So v is equals to under root 2gh. So whenever you need the speed and when there's no loss of energy, the kinetic energy and potential energies are same. So speed is equals to under root 2gh. So this will be under root 2, the gravity is 9.81, and the height from which it fall, that was in beginning of the question, it was given that it fall to a height of 7 meters. So we'll use the same 7. So just substitute 7 and you will get the speed at which this water is falling. If there was a loss, so it's about 12 meter per second. The vertical speed of a water is less than the calculated. Like they said, the water when it is coming down, it has a different speed. Like we calculated 12, but in reality, the speed won't be 12. It will be less than 12. Why? Because when the water is falling, the air particles oppose the motion. When it opposes the motion, so some of the energy will be lost. So in practical, what will happen? Some energy will be lost due to work done against the air resistance. So due to air resistance, some of the energy will be lost. That's why the gravitational potential energy won't be equal to kinetic and it won't give the same result. In question 20, figure 2.1 shows a track for a model car. The car has no power, which can run down a slope due to its weight. The car is released at Q and it comes to rest just before it reaches S and it rolls back. Describe the motion of the car after it starts rolling back and it eventually comes to rest. Like we release a car from Q, it moves towards R and then it stops at S and then it rolls back. We have to explain the motion when the car roll back, like how it will move. So what will happen? This car, when it is moving from S to this point, R, it will accelerate. And when it is moving from R to Q, it will decelerate and it will repeat its motion. Eventually, it will stop at R. Like the car, because it is losing energy. Like car has moved to S, but we don't have to explain this motion. We have to explain from S to R, it will accelerate, speed up, and R to Q, it will decrease. But it won't reach Q because it is losing energy and it will repeat its motion and eventually it will stop at point R. So from moving towards R, it will accelerate, and moving towards point Q, it will slow down and it will move back and forth and eventually it will stop. So it will accelerate from S to R and it will decelerate from R to Q and it will repeat its motion and it will eventually stop at R. So at point R, it will eventually stop. Explain in terms of energy transformations why the car starting at Q cannot pass S. Like if we release a car at Q, why it can never pass S in terms of energy transformation? Because what will happen when the car is moving from Q towards R and then from R to S, some of the energy will be lost. So if it started with 100 joule, it won't have 100 joule, like maybe 20 joule is being lost, so it will have only 80 joules. So why it's not able to pass this point S? Because when the car is moving, it will lose energy due to air resistance, you can also say, and the friction due to work done against the air resistance or friction. Or you can also say drag. Air resistance is also refers to drag, so you can use the term drag as well here. A second car of mass 0.12 is released from point P. Calculate the maximum speed and assume that the friction is negligible. Like we are releasing a car at point P. We are releasing a car at point P and we want to find the speed as at T. So what will the motion of the car? The car will roll back, like car will move back, car will accelerate towards R, then it decelerate and then again it will accelerate. But there is no loss of energy. So if there is no loss of energy, we can say the potential energy at P is equals to kinetic energy at T. And the height from which it is released is 0.5. irrespective of what happened in between. But because there is no loss of energy, so the potential at P is equals to kinetic at T. And then we will use, so we'll say the potential energy, the kinetic energy at T is equals to potential energy at P. Kinetic energy is half mv square and the potential energy is mgh. M will cancel with M. So again, the same formula, we need the speed. This is a common type of a question. So V is equals to 2gh. If I need V, we take a root. So speed is equals to under root 2gh. So 2 times the gravity, 9.8 times the height from which this is released. So we release from a height of the point T was, point P was 0.5 meter. Okay. So we release from a height of 0.5. So this will be 0.5 and then take a root, under root. So you'll get the speed at which this car will move, which is about 3.16 meter per second. Next question, again, it's a work energy and power question. So you will find the whole exercise about this. A farmer uses an electric pump to raise a water. 3.13, okay. So a farmer uses an electric pump to raise a water from a river in order to fill the irrigation channel. So the pump is raising the water and then it is irrigation, adding that to irrigation channel, and which can be used for the farming. Every minute, the pump has raised a 12 kg of a water through a vertical height of 3 meter. Calculate the increase in gravitational potential energy and then calculate the useful power. So 1 mark is for just writing a formula for gravitational potential energy is mgh. M is a mass. So PE, the potential energy, is equals to mgh. M is a mass, which is 12. G is a gravity, 9.8. And the height, it raised to a height of 3 meter. So when you multiply 3 multiplied by 9.8 times 12, that is equals to 58. Multiply, yeah. So 12 times 9.8 times 3, that is 352.8, okay. So 352.8, or I can write 3 significant figures, so I can write 353, and the unit will be joules. We need the useful power because it is lifting, so power is equals to work divided by time or energy. How much energy the pump has used? The pump has used 353 joules, and every minute. So every minute means how many seconds will be there? 60 seconds. So we divided by 60. So 353 divided by 60, that's equal to 5.88, and the unit of the power will be watt. So 5.88 watts it will, joules every second this pump has used up. Question 22, figure 5.1 shows a model cable car. It is driven by an electrical motor coupled to a gear system. As you can see here, there's an electrical motor connected with a gear system, and a model cable car is moving. It raised to a height of 2 meters and the length it covers is 6 meters. A model cable car has a mass of 5 kilograms and is lifted from the bottom pulley to the top pulley in 40 seconds and stop automatically at the top. What is the average speed? So average speed is the total distance over total time. So we have the figure. So what total distance we will take? Because we have two distances are given. One is 6, another one is 2. What distance we will take? Because we need the average speed of the, yeah, so we need the average speed. So average speed is equals to total distance over total time. So total distance is 6 we'll take because that's a distance it covered. And the total time it took 40. So 6 divided by 40. So write the formula for average speed. That will be the total distance over total time. So total distance is how much? That is 6 and the total time is 40. So 6 divided by 40, 0.15 meter per second. Then we need the gravitational potential energy gained. So potential, the height, because then we use the height, which is 2 meter. So the gain in gravitational potential energy, we use a formula that mgh, the GPE or potential energy. So mass, what is the mass given? That's there in the question. 5 kg. So mass equals to 5. The gravitational force is 9.8 and the height which we move to. So it will be 10 multiplied by 9.8. So it will be 98 and the unit will be joules. So 98 joules of energy will be used up. The next, useful output power, like to get the power, it's energy divided by time. So power is work or energy. So 98 joules is consumed. And how much time? It was taking 40 seconds in the that was given in the question. So 98 divided by 40, what's the answer? 98 divided by 40.
2.45.
2.45. So the power will be equals to 2.45 watts. Then we have how the next part is how would electrical power input to a motor compare to your answer. So in practical, what will happen? Like electrical power input, this is output power. So how electrical power input to the motor compare with your answer in A3? Like what is the relation, how they're related to each other? So the input power, this is the output power, and input power is always higher than the output power. Yeah, it will be. That's a good answer, Rabia. It will always be greater. Why? Because some energy is always lost. So input power will always be greater than power output because some power or some energy is lost. So electrical power input will always be greater than output because some energy is lost. Next question, energy from a sun evaporates the water from sea and some of this water eventually drives in hydroelectric power station. Give an account of the processes and the energy change involved. A 4-mark question. You have to write about the hydroelectric power stations. So first what will happen? Because of the heat energy, the water will vaporize, then it condense and then a precipitation or a rain that will the falling water will form the rakes, and when we stop the flow of the water will have a gravitational potential energy. When the water flow through the dam, the potential energy change to kinetic, and when it rotates the turbine, it produces electricity. So you have to write all about the water cycle here. Anyone having a doubt? Should I write the model answer or is it fine? Because it's related to the water cycle and the hydroelectric power stations. The next is in hydroelectric power stations, 200,000 kilogram of water every second fall through a vertical distance of 120. It leaves the turbine at a speed of 14. We need the gravitational potential energy, mgh. So m is a mass, which is 200,000. G is a gravity, 9.8. And h is a height, vertical distance, 120. So this will give us the energy What's the answer for this? 200,000 into 9.8 into 120. It will be in exponent. Tell the answer in exponent. So, okay, they said, sorry, I did not read. Use a gravity. Okay, yeah, that's right. So if they said use gravity as 10, you will take as 10. If they say, if nothing is mentioned, take 9.8. But because, as I mentioned, these are the old past exam paper questions. So there they were using 10, but now it is 9.8. What you have to use? But we'll use 10 according to the question which is given here. So this will give us 2.4 exponent 8. Then calculate the kinetic energy. So what will happen? It leaves at a speed of 14. So kinetic energy will be half mv square. Why we did not consider potential equal to kinetic? Because it did not mention that it is equal. They give us a speed. So then we'll use half mv square. M is a mass, which is 200,000. And the v is the speed, which is 14 square. This will give us the kinetic energy, which is 1.96 into 10 to the power 7. So you can see the potential is higher than the kinetic. And what is the obvious reason? The obvious reason is some of the energy is lost due to the drag or the air resistance. So the potential won't be equals to kinetic, as there is always an energy loss. In question 24, this is athlete is there performing a pole vault. You have to describe the energy changes which happen. Question 24. So, and the transformation. So when he is standing, which form of energy he will have? He will have a chemical energy. I'm writing in short, CE. Then what will happen as he runs? His chemical change to kinetic. Then when the pole is bent, as you can see here, this pole is bent. So this will have elastic strain energy. When he reaches a certain height, he will have a GPE. When he hit the mattress, it will produce sound. It will also have heat, and it will also have some elastic strain as a mattress will deform. So he will also have elastic strain. So first he's having a chemical energy. When he run, his chemical energy change to kinetic. He use it to bend the pole. So kinetic turn into elastic strain. He reaches a certain maximum height, gravitational. When he's coming down, kinetic, and eventually the kinetic energy turn to heat, sound, and elastic strain energy. A diver climbs some steps and he jumps into a pool from a height of 8 meters. Increase in gravitational and we need the speed. So same idea. Increase in gravitational potential energy, GPE, is equals to mgh. M is a mass 65, G is a gravity 9.8, and H is a height 8 meter. You multiply, you get GP. Then the speed at which the diver, so if there is no loss of energy, the KE just before hitting is equals to GP. The kinetic energy is half mv square and the potential energy is mgh. So m will cancel with m. So half v square is gh, or v square is equals to 2gh in a root. So it will be 2 into gravity 9.8 into the height. He jumped from a height of 8 meter, take a root. That will give you the speed at which it's about 12 something, 12 point. If you take 10, the gravity is 10, it will be 12.6. I think it will be 12.5 something meter per second. And you can clearly see that it does not depend on the mass of a diver. Like example, if there's a diver of mass 65 kilogram, another one is 85 kilogram. If they have the same, they are jumping from the same heights and there is no air resistance, then they will have the same speed. It is irrespective. So the mass of an object does not affect the speed at which it hits if there is no air resistance. Just check this value. I did not calculate. I'm just saying, like, this is 2 times 9.8 times 8 and take a root. What answer you get, just write it here accordingly. Then another diver from a same platform, he dives and he perform a somersault, like he flip. Discuss whether the speed will be same, greater, or equal. So this diver, he did not perform a somersault, but another diver is performing a somersault and he's going inside. Both will have the same speed. Why? Because as we assume, we ignore the air resistance. If we ignore the air resistance, so there is no loss of energy. So if there is no loss of energy, they will have the same, like same potential energy. So at the end, they will gain the same amount of kinetic energy, and because they have the same distance fallen, or they have the same accelerations, or there is no loss of energy. So you can mention here, 1 mark is for mentioning same, 1 mark is for mentioning because they have the same gravitational potential energy, and 1 mark is for mentioning that there is no loss of energy, so they will have the same kinetic energy. So a diver performing a somersault or the diver jumps without performing somersault, both will have the same speed because there is no loss of energy. And this question, the mass of a skier, including its equipment, is 75. So we need the decrease in potential, gravitational potential energy. We use a formula mgh. So mass is 75, gravity is 9.8, and the height is 880. You will get the gravitational potential. The total resistive force, he move a distance 2,800 and the force is 220. We need the work done. Work done is force into distance. Against the resistance of 220 times 2,800. When you multiply, you will get the answer, like how much work is done against the resistive force, which is about 606. This is 6.5 exponent 2, 6.5, exponent 5. And this is, if you take 10, the gravity 10, it was 6.6 exponent 5. Now, we need the kinetic energy because what will happen? He has this potential energy. He has a potential energy of 6.6 into 10 to the power 5. He lost 6.5 into 10 to the power 5 joules because of the friction. What will the kinetic energy at the bottom? So we'll just subtract the two numbers, take the difference. The gravitational potential energy minus the work done, we'll get this kinetic energy. And suggest why a skier bend his body as shown in figure 3.1. So why he bends his body? What is the advantage? Because when he bends his body, he reduces the surface area in contact. So when he reduces surface area in contact, he reduces the air resistance. So there will be air resistance, but less air resistance. As a result of a less air resistance, then less energy will be lost because of the friction and more energy will transfer. So he will move at a much higher speed. So because less amount lost, so more will be kinetic energy. Is it clear? This was an exercise which was related to work, energy, and power, the weekly homework. Anyone having a doubt or a question in any part? Okay.